Today we're looking at lesson 4-5, which is on scatter plots and lines of fit. So these are three examples of relationships that you might see when you're looking at a scatter plot. A scatter plot is basically a graph that has many points plotted on it, and sometimes it'll show a relationship. So for the first one, this is going to show a positive relationship because if you look from left to right, and I've drawn the line through there, you can see that the line is going up from left to right. So this is going to be positive. And they call this correlation, okay? So a relationship is called a correlation. So this is a positive correlation. Now, same idea for the next one. Look from left to right. I've drawn the line down, and it's because most of the points are going down from left to right. So that would be a negative correlation. And then notice the third one, I do not have a line drawn through it because there's no pattern of the points, and the points are kind of scattered all over the place, literally. So this would be no correlation. So when we're trying to come up with a line of best fit, which is the line that I drew through most of the points for the first two examples, then we're looking for whether it has a positive or negative correlation. If it does not have a correlation, you cannot draw a line of fit. So here we're looking at a graph. We have a bunch of ordered pairs plotted. So from left to right, it looks like the ordered pairs are going up. So if I were to draw a line of fit, my line of fit would go through as many points as I can, and it would be going up. So that means this has a positive correlation. Now we're given 4 steps if we're asked to, if we're asked to write an equation or a linear function from the graph after we've made the scatter plot or plotted all the points. So the first thing obviously is to make the scatter plot. So plot the points on your graph. They usually give the points to you in terms of a table. So you're going to plot the points from the table and then look at the graph to determine whether there's a relationship, so if it's positive or negative. And if there is none, then you can't do any more of the steps. But if there is a positive or a negative relationship, then you can draw a line, and you want to draw your line for step 2 through as many points as you can on your scatter plot, but you don't obviously need to draw it through every point. Third step would be to use 2 points on the line that you drew to write an equation for the line. So we've already done work with using 2 points to write equations. Here, this is the exact same process. The 2 points, though, are going to come from your graph. And then you're going to use the line of fit once you get an equation for your line of fit to make predictions. So we're going to do all 4 of these steps together. So here's the data that I'm given, and this is talking about as the years go by, it looks like the sales are going down of a particular object. So it looks like if we were to graph these, that it would probably be going down from left to right, but we're going to graph them anyway. So we need to create a graph. And usually with real-world problems, you only need one quadrant. So this is a graph about sales on a particular year. If we think about sales and years, years is time, and remember I always told you that time is independent, so that would make it the x variable. and then sales then would have to be the y variable. So we have the years and the sales. The years go from 2000 to 2008, so we're going to label that. We could probably just go by ones. Of course, you'd be doing this on graph paper so that it's a little straighter. Almost out of room here, but one more. Okay, so there's my years, and then my sales range from about 13,000 all the way down to about 5,000. So we have to have a range of values from 13 to 5 at the very least, and we can just label them that they're in thousands. So I would say we could just go up by ones. And maybe go all the way up to 14. We know that that's in thousands, so here we're going to just plot the points as best we can, and they're going to be a little bit estimated, but we have 2,000 and it's about 13,000 for sales, so that is going to be a point at about 2 and a little bit above the 13 there. And then we're going to keep going. 2001 would be a little under 13,000, so 2001 is going to be a little bit lower. Then again, we go just a teeny bit lower for 2002, but not really that low, much lower. And then 2003, oops, is going to be 11,000, so that's going to be a little bit lower again. And then we keep going. So I'm just plotting the points here. And you do the best that you can to make them as accurate as you can. Okay, and then we are going to draw our line of fit, because we're going to try and get an equation from here. So I'm going to draw my line going through as many points as I can. It still does need to be straight, but it does also need to be going through at least 2 points. So I draw my line like this. It's a little bit off, but it's going through as many points as I can there. And what I'm going to do with that is I'm going to pick 2 points that are next to each other, and I'm going to use those to create my equation. So let's say I choose the first 2 points. I have 2,000, and then I have about 13,215. And then I have, the next point would be 2001, and I'm using my table here to see the exact value, 2001 and 12,909. So to write our equation, we assume it's going to be slope-intercept form. when it says write an equation and it doesn't tell you the form. So with this, remember, we need to find the slope first. So I'm going to subtract my y's over my x's. So I get 13,215 minus 12,909, about 306 over negative 1. So I'm going to say that it's about negative 306. Now, to finish our equation, again, we've already done something like this before. Remember, we take a point, either one of the points we use to find the slope, and we plug in the y-coordinate for y and the x-coordinate for x to solve for b. So let's pick our first point. Doesn't really matter, but y goes in for y. X goes in for x, and I'm going to solve. So I multiplied negative 306 times 2,000 first, and then I'm going to get b by itself by adding the 612,000 to both sides. So I get 625,215. So if I put that all together, negative 306x plus 625,215. And that would be my equation. Now it says use the equation for the line of fit to estimate CD sales in 2015. Well, the years represent X, so we're going to put in 2015 for X. So we're plugging this in, and then we're solving for Y. So I multiplied negative 306 times 2015, and I'm going to add that to 625,215. And it gives me about 8,625. So the sales of CDs is going to be about 8,625 in thousands, so that would have to add 3 zeros, so it actually is 8,625,000 if you want to think about it in a real-world type setting. And that concludes Lesson 4-5.